Hi, welcome to UML session. Today we are going to start a very important topic called UML. The full form is Unified Modeling Language, but first of all we'll try to understand what exactly is this language. Is it like C or C++? Is it like Java? Is this language like a C# or Visual Basic? Is it a rapid development tool, or what exactly it is? Right? And we'll see some of the examples and we'll try to understand the basic concepts of UML in this session. So let us start. So the agenda for this UML course is, first we'll start with introduction to UML. What is UML? We'll understand what is the modeling concept, what is the heritage, how it is started, who all have been contributing to the UML overview, and then modeling. What are the basic modeling elements in this one, like classes, instances, attributes, operations, and relationships. Then we'll go little deep inside the relationship concepts in the model. What are the various kinds of relationship? Association, dependency, aggregation, generalization, realization, notation. So these are the various kinds of relationships. And then finally we'll start getting into model and diagrams. Now, number of times we'll just say that models and diagrams. Although models and diagrams are little different, but for our session we'll just keep it simple, that using diagrams you are modeling a system or a behavior. So we'll understand why we build models, UML model views, and some of the tools which we use it. And at the end, the most important part which we have to understand is that in UML, what are the various kinds of diagrams? Use case, class, object, component, deployment, sequence, collaboration, state chart, and activity. So that will kind of completes our UML course for basic of UML. So this is not an advanced course of UML, it is a basic course. So that is good enough to get anybody who is completely new to this concept of modeling to start it. So here it is introduction to UML. Now before that, my first question is that why we build model? And modeling is not something new, it has been there for generations. What model does is that it is a simplification of reality. So if you are building a car, you need to model it, that how it will look like. What will the basic components? What are the basic structure? So what we are talking about is how to model a software or system which we are going to build. So it is, let us assume that you are building a complex building, 10-story building, or a hotel, or a resort, or a car. You always model it first, to design it, to create few diagrams that how the structure will look like, to understand how the various component of this final product will interact with each other, what are the various states it will look like. So those are the things which comes in the modeling. So model is nothing but a simplification of reality, what we do, and that is what it does. So we build models so we can better understand the system we are going to develop. And by doing modeling, it helps us to visualize a system. It permits us to specify the structure or behavior of a system. The model also gives us a kind of a template that guides us. So this is very important, right? That guides us in constructing a system. So if I have a template, then next time when I am going to model something similar, I can use that template to develop my system, or at least that template I can pass it to all the people who are involved in developing or creating that system. So that's why model is very important, because you can visualize how it will look like, you can specify the structure or behavior of the system. And every time I'm talking about software system, but this is applicable to any system. It doesn't have to be software. It can be used for manufacturing a building, manufacturing a car, creating a building, or developing a resort, developing anything, a small thing, building a computer. You need a model. So that was the concept of model. Now the same concept we are going to utilize for our software development. So this is a concept of model. Models also documents the decision we have made. So what happens is that you can pass around this document and contribute and discuss and change, modify, communicate. All of that you can do if you have something written in black and white which talks about what is the model, what decision we have done, why we have done. All that thing is required, and that's why we need a modeling of a system. Okay. To summarize the same thing which I just said, the model helps you to understand the problem better. It helps to communicate with the stakeholders. It helps you to find the error or omission, something are you missing. Because when you analyze the whole model from various perspectives, the structure, the components, the behavior, the state, the sequence, how the various component will work, all of those things when you discuss and document, you are more liable to find out the errors and omission rather than just assuming that yes, I have everything in my brain with me. So it definitely helps a lot. It also helps out to plan out the design so that once you have the model, you can design it much better instead of having no model and just design it itself. And it takes further, we have developed now in the world, there are a lot of companies who have developed tools in which even if you just put it the models, if you design the models, it can generate the programming code in C, C++ or Java or other languages. So this is specific to software, but this is also a lot of tools are there which helps you to generate the code out of the model itself. Now, what exactly is UML? So we have understood about the modeling. So now let us understand about the what exactly is UML. UML is a language which is used for modeling a software related system. So basically what it provides is a language whose vocabulary and rules focus on conceptual and physical representation of a system. So basically it language to visualize a system, how the software system will look like, is specifying the various components on your system, what are the classes, what are the objects, what are the subcomponents, how they will interact with this, and used for constructing and documenting the artifact of a software intensive system. So this is what UML is all about. It is used for visualizing, specifying, and language for constructing. Visualizing means some things are best modeled textually, others are best modeled graphically. In all interesting systems, there are structures that transcend what can be represented in a programming language. So that's why it is easier to visualize, and you can language for specifying unambiguous and complete. The UML adds the specification of all the important analysis, design and implementation decision. The most important part, it is not a visual programming language, but its model can be directly connected to a variety of programming languages. So it can generate a language, it can generate the code in these languages itself. But this is done by the UML tools. So let me just repeat. UML is a language for visualizing a model or system, specifying about the system you are going to build, constructing the diagrams and all, and documenting it. Now, once we are done with this one, let us get a very brief summary of what UML is. We have discussed data modeling concept, business modeling we can create. So UML stands for Unified Modeling Language. It combines the concept of data modeling concept like entity relationship diagram you can create. You can create a business modeling like workflow. You can create a object modeling. You can create what are the various objects in your software which you will create, how they will interact with each other. All of that you can design or create the diagram called object diagram in UML modeling. You can create a component modeling by creating a component diagram, how the components will be interacting with each other. UML is a common language for specifying, visualizing and all. It can be used with all processes throughout the development life cycle. The UML is very simple and useful framework to create model for the software system you are going to build.